If you're meeting a friend at 3 o'clock, how late would be too late for them to show up? Would it be annoying if they were 15 minutes late or about 5 minutes late? Equally, if they were a little bit early, would that be weird if they were a quarter of an hour early? So let's say, for example, you wouldn't be annoyed if they were 10 minutes late, and it wouldn't be weird if they were 10 minutes early. So in that case, you'd say 3 o'clock, and really it's plus or minus 10 minutes. Now that's the same thing as uncertainties in physics, which is what today's video is about. We're going to cover uncertainties in a single reading, in multiple readings, we're going to do percentage uncertainties, and how to combine them. Now, a really common measurement you'll make in a lab is using a ruler. So we're going to use that as a starting point to understand what uncertainties are when we're doing practical tasks. So let's say I'm measuring the length of something. It could be a pen, it could be anything. And I'm using a standard ruler and it measures 6.2 centimeters. Now, depending on where the pen lines up, that could be as low as 6.15 centimeters or as high as 6.25 centimeters. Your measurement lies somewhere in the middle of those two values, even though you might be able to see it on a ruler. So we'd say the uncertainty in those readings, and we're going to call it the absolute uncertainty, is equal to 0.05 centimeters. So that's the absolute uncertainty. That's the plus or minus from the value which you are stating. Now, when you're measuring something with a ruler, you've also got the other end of the object to consider, because you have to line it up with the 0 centimeters part of the ruler. So at this point, it could either be as high as 0.05 centimeters, or it could be as low as technically minus 0.05 centimeters, which is half a millimeter less. So our absolute uncertainty there would be plus or minus the same, 0.05 centimeters. Now, to combine those uncertainties together, we've got two different measurements involved in our reading. So we say the total uncertainty is going to be added together 0.1 centimeters. So 0.05 added to 0.05. So we'd express our overall reading as 6.2, and that'd be plus or minus 0.1 centimeters. The same thing applies with a protractor. When you're measuring with a protractor, you're lining up the 0 degree angle. You're also lining up the angle itself. So it's half a degree for the 0 line, it's half a degree for the angle you're measuring. So we add them together to make 1 degree as our absolute uncertainty. Now, to work out the absolute uncertainty with any reading, unless you're told it in a question, for a single reading, we use the resolution of the instrument. So the resolution of the piece of equipment you're using, if you don't know what that is, have a look at my practical definitions video, is the smallest interval a instrument can measure. So that'd be 1 millimeter for a ruler, 1 degree for a protractor, and let's have a look at some other measurements. So let's say for a stop clock, for example, what would the uncertainty be with one reading? Let's say 2.46 seconds. Well, the smallest thing a stop clock could go up or down by is 0.01 seconds in this case. So the resolution is 0.01, so that's also going to be our absolute uncertainty in this case. So it's 2.46 plus or minus 0.01 seconds. Now that applies to all digital instruments, just use their resolution unless you're told differently in an equation. Now let's look, instead of a single measurement, what happens if, like with lots of readings you have in physics and in science, you take repeats. So let's say I've got 3 repeat readings for a time taken for something to fall. One is 2.46 seconds, one is 2.27, the other is 2.58. Now the uncertainty we said earlier must be 0.01, but that doesn't make sense because the values should all lie within 0.01 of each other in that case. The uncertainty is the range in which your value should lie, and that doesn't happen, so we have to use a different method to work this out. So the absolute uncertainty in repeat readings or multiple readings we find by basically using the range. So we find the range of values and we divide by 2. So in this case, my highest minus lowest value is 2.58 minus 2.27, which equals 0.31 over 2. That equals 0.155. We're going to keep it to 2 significant figures or 2 decimal places in this case, because that's what our values are to. So that equals 0.16 if you round up to 2 decimal places. So that means then for our mean time, we'd express it with an uncertainty. So the mean time happens to be 2.43666. Round it to the same number of decimal places, and then we say plus or minus 0.16, which sounds a lot more reasonable given the widespread of values we've got. So that would be our absolute uncertainty. Now the next thing we're going to look at is how to calculate percentage uncertainties. Now once you've got your head around finding out absolute uncertainties, percentage uncertainties should be relatively straightforward, because the same way you find a percentage of anything, you get the uncertainty and then you divide it by your value. So as a percentage uncertainty, in this case my uncertainty is 0.16, my value, my mean is 2.44, so I've got a percentage uncertainty, obviously times it by 100 to make it a percentage, which equals in this case 6.56%. Now, you could also be asked for a fractional uncertainty. You won't see it that often, but that's basically the same thing, but it's not converted to a percentage. So you can make it a fraction. So, for example, this would be 6.56 over 100 or 656 over 1,000, or as a flat decimal like that. But percentage uncertainty, really important. You can calculate it using this equation here. Next, we're going to look at combining uncertainties together. Now, this is where things do get a little bit tricky. Next up is how to combine uncertainties. Now, this does get a little tricky, so make sure you're paying attention because this will get you lots of marks in the exam if you can do this. So the first job, if you're combining uncertainties in any two values, is to find the percentage uncertainties. So the example we're going to use is one involving distance and time. And let's say I've got a distance of 1.51 meters. I'm trying to find the speed. Okay, so we need to use an equation, as we almost always do when we're combining uncertainties. To find the percentage uncertainty, we find it out with distance first. So therefore, we've got a resolution of 0.01 over 1.51, gives us percentage uncertainty, same method of 0.662. So the speed calculation then is going to be my distance divided by my time, same time as before. Now that happens to be 0.6185, which I'm going to round to kind of three significant figures, which is 0.619. So what we then do is once we've got our percentage uncertainties, we have to basically add them together. So this example will be the percentage uncertainty for distance added to the percentage uncertainty for time. So I've got those two values already. I've worked them out earlier. So my distance is 0.662 and my time value I calculated earlier is going to be 6.56. So we add those two together to give us an overall percentage of 7.22. So that's our overall percentage uncertainty with speed by combining the percentage uncertainties of distance with time. So now let's actually use that as work out as a percentage of our actual speed value. So 7.22% of our value for speed happens to equal 0.045, again to the same number of decimal places as our value, and therefore we can quote our speed overall to 0.69 plus or minus 0.045 meters per second. Now normally that's about 3 or 4 marks if you can get it in an A-level exam, so make sure you know how to do it. So general rules for combining uncertainties: if whatever you're doing in your equation, if you're timesing two values, you add together percentage uncertainties. If you're dividing two values, you add them together. If you're squaring a value, double the percentage uncertainty. And if you're cubing or quadrupling, you times the percentage uncertainty by what your index is.